Hi, I'm Candace Ross, and I work with Boris Katz at MIT. So when we think about human intelligence and cognition, there are some things that come to mind. So one, we know that humans are really good at adapting to new tasks. So here, for instance, on the top left, you can see a woman drinking from a fire hydrant. This isn't a normal task, but she can still pretty easily adapt to doing that. We also are pretty good at recovering from errors. So if you've been walking and tripped over your shoelace, you may have stumbled a bit, maybe even fell over, but you could stand back up and continue on. And lastly, we are very good at learning from our environment. This is something we do every day by interacting with objects and learning new things. Now I want to contrast this with machine intelligence. So for machines, they often are unable to perform new tasks. A neural net trained on classifying cats and dogs will have a very difficult time trying to classify trains and cars, for instance. Also, we have difficulty machines with recovering from errors. So the DARPA Robotics Challenge is a good example. You can go on YouTube and see all of the robotic fails. And finally, they're often disconnected from perception. This is what I'm most interested in, because human intelligence is intricately tied to perception. So I pursue, in particular, language learning. If you think about a child, we know they rapidly acquire language, often with few training examples and very limited supervision. So in terms of language learning, we often have a sentence, we want to get to some higher order conceptual representation. So for instance, a sentence, "Mommy passed Daddy the milk," a child parser might take the sentence and get to some representation mapping these words onto objects. For a machine, we have the semantic parser, which similarly takes a sentence and maps it to representation. In this case, it's the lambda calculus representation to the bottom right. But I mentioned perception, so in particular, I'm interested in grounded language learning. In this case, grounding language in vision. So we have that famous sentence, "I saw a man on the hill with a telescope," and it's ambiguous. It means either I have a telescope or the man has a telescope. So a child parser, seeing perception, can quite easily disambiguate the sentence. It'll see either the left or the right, in real world. For our semantic parser, if it has just the sentence, it will have trouble disambiguating. You might get these two representations in the bottom right. Again, either telescope's with me or it's with the person. But by incorporating vision, so this model will see either the image on the left or the right, it can disambiguate and give us the correct representation. And this is a pretty simple example, just some stick figures, but in the data set I use, we have real-world videos along with sentences. And so our goal by grounding in vision is to help this to learn more quickly and more similarly to a child.